Okay, so we have 6, 7, and 8 to do on your projectiles fired at an angle sheet. So number 6 first. It says a ball is thrown to the catcher from left field at distance of 80 meters. So this is 80 meters. Its average horizontal velocity component is 20 meters per second. So I'm telling you Vix is 20 meters per second. You don't know Vi, and you don't know Viy, and you don't know theta. What is the maximum height reached? So you're looking for delta dy. Okay, so if we divide up into our x and our y, Vix, they told us, was 20 meters per second. Ax is 0. And delta dx is 80 meters. So from this we can find our delta t. In our y direction, we don't know Viy. We know Ay is 9.81 meters per second squared down. So if we have our t, we can use our t and our Ay to get our Viy at the halfway point, like using the halfway point. Okay, so first let's find our time. Delta dx is equal to Vix delta t, 1/2 Ax delta t squared. This goes to 0. So delta t is going to equal delta dx over Vix. So 80 meters over 20 meters per second. So delta t is equal to 4 seconds. Okay, so then we can come over here because it's ground to ground, and we can use Ay is equal to Vfy minus Viy over delta t, and because it's ground to ground, we can find the time it takes to go up, or use the time it takes to go up, to find our Viy. So Viy is going to be equal to negative Ay delta t u. So Viy is going to be equal to negative 9.81 meters per second squared, and the half time is 2 seconds. So Viy is equal to 19.62 meters per second, and that's up. So now that I have my Viy and I have my Tu, I can find my delta dy max. So delta dy max is equal to Viy delta Tu 1/2 Ay delta Tu squared. So delta dy max is equal to, that was 19.62 meters per second, 2 seconds, plus 1/2 negative 9.81 meters per second squared times 2 seconds squared. 2 seconds squared is 4, half of 4 is 2. So this is going to be 19.62, 39 point, whatever half of that is, take away 19.62, and you will get 19.62 meters up. Number 6. Number 7. A projectile is shot from the edge of the roof of a building, which is 50 meters high. The muzzle velocity is 80 meters per second at an angle of 40 degrees. So muzzle velocity simply means the barrel of the gun is often called the muzzle. So it's simply telling you the Vi as it leaves the gun, and that's 80 meters per second. And it's at an angle of 40 degrees. Okay, it's going to go up and come down. And it says the building is 50 meters high. What is the distance from the base, and what is the velocity as it's just going to hit the ground? So in the x direction, we know Vix is equal to Vi cos theta. We know Ax is equal to 0. We don't know delta, we don't know delta dx, we don't know delta t. In the y direction, Viy is equal to Vi sine theta. Ay is equal to negative 9.81 meters per second squared. Sorry, this is down. This is up. I never put my negative there. I'm not sure why I did. We don't know delta t. Okay? But we do know delta dy. It is 50 meters down. Okay? So we can find our time. We can find our time by doing the quadratic. So delta dy is equal to Viy delta t 1/2 AY delta t squared. So negative 50 meters is equal to VI sine theta delta t plus 1/2 negative 9.81 meters per second squared delta t squared. I know I didn't fill my other things in yet. I'd bring the terms to this side, so my 4.905 meters per second squared t squared will be positive, minus 80 meters per second sine of 40 times delta t minus 50 meters equals 0. So delta t is equal to minus a minus, so plus 80 meters per second sine of 40. It's not going to be pretty, so I'm not going to fill it in until the end. And then negative 80 meters per second sine of 40 squared minus 4 times 4.905 meters per second squared times negative 50 meters. And all of that is going to be over 2 times 4.905 meters per second squared. Delta t equals, I think this first term is 51.423 meters per second, plus or minus, under the square root, need a calculator. So what is it? 80 times 40 sine equals squared. Under the square root, the first term is 2644.325831 meters squared per second squared. No, you don't really need to keep all of that. And then it's going to be plus, because of the negative, and for 2 times 9.81 times 100, so 981, I think, meters squared per second squared. On the bottom, it's going to be 9.81 meters per second squared. So you get delta t is equal to 51.428 meters per second, plus or minus, and then under the root, sorry, I'm just double checking. Under the root, you should have 3625.325831 meters squared per second squared over 9.81 meters per second squared. So delta t will be equal to 51.428 meters per second plus over 9.81 meters per second squared. And delta, oops, I'll do it down here, delta t is equal to 51.428 meters per second minus over 9.81 meters per second squared. And what that is 60.2107 meters per second. Okay? And so when you do the top one, and this is also negative 60, when you do the top one, you're going to get a positive number. You end up getting 11.38 seconds. When you do the bottom one, you get negative 0.8957 seconds. So clearly it's going to be this one. Okay, so it wants the distance from the base of the cliff. So now you go up here and do delta dx is equal to Vix delta t, 1/2 ax delta t squared. This goes to 0. So delta dx is equal to 80 meters per second cos of 40 times, what was I doing, plus 40 sine times 80, and then divided by 9.81. Sorry, I just didn't have the time in my calculator. So times 11.37958 if you want it to be specific. And you get a delta D of something like 697.4 meters. Okay? And I'm going to run out of time for the part that I actually wanted to talk about. B, the velocity of the projectile when it hits the ground. So you're looking for the projectile when it hits the ground, Vf. So you need to find Vfx and Vfy. Okay? Vfx should be easy because Ax is 0, so Vfx is just going to equal Vix. So it's going to be 80 meters per second.